Okay, so these questions are very largely about wording and pulling out the wording as we go. So for this first question, you can pause and read it now if you haven't done so already. The mean price of the house is equal to 280,000. That's right, I can do math. Okay, with a standard deviation of 8, and we'll do that one, of 80,000. Now, this is the population standard deviation, not the sample. Okay, 50 samples of house prices were randomly collected in the city. So there are 50 samples of house prices, but each sample contains 200 houses. So in this first case, we're going to be using the number of houses in the sample. So we'll just note this important information down to start off with. 50 samples, 200 in each sample. Okay, so that's the important information that we need for now. Let's start solving. We're going to determine the mean and the standard deviation of the sampling distribution of the house prices. So the sampling distribution, there are 200 in each sample. There might be 50 samples, but that's relating to something else. So let's get started. So first thing we're going to note down, U is equal to 280,123, and the standard deviation of the sample is going to be equal to our formula. Now, this one is in the formula booklet, but you need to know how to apply it. So the population standard deviation goes on top there, divided by the number that are included in that sample. So that is the 200, not the 50. Okay, so now when I chuck that into my calculator, I'll get 5656.85. So that's the standard deviation of the sample. Okay, next one, determine how many samples the mean price would be expected to be above 20. So that one here is referring to not the 200, how many of the 50 samples are going to be expected to have a mean above this. Okay, so sounds hard, not really that hard. Let's assume, now this is the first thing that we need to do. Anytime you see a question like this, you have to first assume. So assume normal distribution because n is greater than 30. So as soon as we assume that it's normal distribution, that means that we get to start using normal distribution to work this stuff out. Now, we are looking for the probability that the housing price in the sample is greater than this. So we're going to be using the part of our calculator. We're going to go distribution, normal, NCD. Now, in your exam, make sure that you note down what you put in the calculator because you can still get partial marks. Now, when I look at something like this, I normally draw a little picture underneath. So X has to be larger than 29,000, which means that this is that, and the upper bound is going to be all the way up to as close as we can get to infinity. So here we'll have lower as 290,000, upper is 1 times 10 to the power of 99. Our standard deviation is the sample standard deviation, 5656.85, and our mean is equal to 281,234. Now, make sure that when you're doing this, you're being careful that you don't flip the standard deviation and the mean around in your calculator. So I have to open up my calculator, which I normally already have done. Find my little emulator here. Let's move this around so you can see my screen at the same time. If I knew how to edit, I'd cut that bit out. Okay, so now we've got statistics, execute. Distribution, we assumed that it was normal. Yeesh. Okay. Try that again. Distribution, normal. NCD, the computer is clicking around wildly. Okay, the lower for this one is going to be 2, 9. 1, 2, 3, 4. The upper is going to be 1 times 10 to the power of 90. Stop clicking around. 99, execute. Our standard deviation is 5656.85. Execute, and our mean is the mean that we were originally given. Execute. Okay, and we get that our probability of this occurring is that number right there. So then that means that the probability that X is this is equal to 0.0385. Okay, I'll round to 4 decimal places there. Okay, so next thing, determine how many samples the mean price would be expected to be above this. So this is the probability. There are 50 there. You should remember this from grade 9. All I have to do is to work out the number in the samples, I do the n multiplied by the probability. So it's the 50 samples that are going to be included multiplied by 0.0385, which gives me approximately 2.